Hey guys, welcome back. Today is day 53 and it's our third day of learning about the properties of exponents. So today we're going to talk about negative exponents and zero exponents. So we have learned that zero to uh, anything to the zero power is equal to 1, okay? So except that if you have a 0 to the zero power, a cannot be 1 or the base cannot be 1. So example, 5 to the 0 is equal to 1. All right, a negative exponent, we want to have our final simplified answers without negative exponents. So a negative exponent is actually equivalent to the reciprocal. You take the base and make the reciprocal and then make the exponent positive. So for instance, 2 to the negative 1 power is the same as 1 over 2 to the 1 power, which is really 1/2. Okay. And a to the n is the reciprocal of a to the negative n. So if we had 2 here, that would be the same as 1 over 2 to the negative 1. Okay. Examples. So 3 to the negative 2 power would be the same as the reciprocal, 1 over 3 squared, which would be 1/9. Okay. 7 to the 0 power, that would be 1. Okay, 1/5 to the negative 2. Let's take the reciprocal of 1/5, which is 5, and square it, and so that becomes 25. And 0 to the negative 5 power is the same as 1 over 0 to the 5th power, which is undefined because you cannot divide by 0. All right, so a to the negative n is defined only for non-zero number a. Okay, so it can't be 0. All right. So let's look at some more. Let's try some examples. Again, 2 to the 3rd power, that would be equal to 1. All right, negative 8 to the negative 2, we're going to say 1 over negative 8, and we're going to take it to the positive 2 power, square it. So this would be 1 over 64. Okay, 1 over 2 to the negative 3. If I take the reciprocal and make it positive, I just get 2 to the 3rd, or 2 cubed, and that would be 8. And this one, you could say multiply. So you've got your power to a power. So this would be 4 to the negative 4 power, which is the same as 1 over 4 to the 4th, which would be 1 over 256. Okay, 1 over 3 to the negative 4th. Let's just make it 3 to the positive 4th. We take the reciprocal there, and that would be equal to 81. And here we have the same base 6. Negative 4 plus 4 is 0. And anything to the 0 power is just 1. Okay, so with a couple more, a little more kind of complicated examples, here we have 2xy negative to the negative 5th, and then we're cubing it all. So if I take, and I start using the, if I take each of the factors to the 3rd power, I would take 2 to the 3rd power, x to the 3rd power, and y would be to the negative 15, because power to a power we multiply. All right, 2 to the 3rd is 8, 8x to the 3rd, and we can just put y to the 15 in the denominator and make it positive, and that would be our final answer. So we just moved that y to the negative 15 to the denominator and made it positive. All right, example 12, I like to start out with just a fraction bar, and if I have negative exponents like 2x to the negative 2, I'm just going to start out and move that to the denominator and make it a positive 2. Okay, y to the 5th would stay back up in the numerator. Now, in the denominator, I have a negative 4. I like to pull my coefficients out front. And then I've got x squared, y squared. Okay, so that might be my first step. And yours might be similar, but maybe not exactly the same. My second step, I'm going to take what's in parentheses. So I've got negative 4, and that's going to be times 4, because 2 squared is 4, x squared. Then I have my x squared and y squared. Okay. So then my next step would be, I've got, let's do it over here, y to the 5th, negative 4 times 4 is negative 16. My x would be, if I multiply, I add the bases, 2 plus 2 is 4, and my y is squared. Okay, and then I can only have one occurrence of the variable, so I've got to divide y to the 5th by y squared, and when I do that, I get y to the 3rd, and then it's negative 16x to the 4th in the denominator. And there's my answer. Okay, so let's go back and try a few. You might want to pause the video right here and try a few and then see how you do, or look at the key that's posted on Schoology. But I would take this as 1 over 4 to the 3rd, which is 1 over 64. Okay, 2 to the 0, that's easy, that's just 1. Negative 3 to the negative 1 power would make it a fraction and make it to the first power, so it's just negative 1/3. Okay, because negative 3 to the 1 power is just a negative 3. 1/4 to the 0 power, that's also 1. Okay, number 17, because it's to a negative power, let's take the reciprocal of 2/7. That would be 7/2, and let's make that exponent positive. Now we've got the power of a quotient rule, so this would be 7 squared over 4 squared, which would be, oh, not 4 squared, sorry, that's 2 squared. I got ahead of myself on that one. Let's erase that and make it 2 squared. Okay, so this would be 2 squared. So we've got 49/4. Okay, number 18, when we look at 18, we've got, we add our exponents, so this is 2 to the negative 5, which is the same as 1/2 to the 5th, which would be 1/32. Okay, 19 is kind of easy. All right, I've got y to the negative 2, so I'm just going to put that in the denominator and make it positive. There's my final answer. 20, I've got the same base, so I'm going to be careful here. I'm either going to subtract. So negative 3 minus 2 is negative 5, so I end up with 3 to the negative 5 power, which is 1/3 to the 5th, which is going to be 1/243. Okay, and when I subtract here, my base is 6. Negative 3 minus a negative 2 is a negative 1, so I end up with 6 to the negative 1 power, which is 1/6. Okay. Moving on, let's try the next few. Okay, so 22. When we look at 22, we've got, we're multiplying our x's, and the rule is we add, so we've got x to the 5th. And our y is going to be to the negative 4 plus 2 is negative 2. Since we can't have a negative in our final answer, we're then going to say x to the 5th over y squared, and that would be our final answer. All right, 23, we're just going to pull the y to the negative 3 and put it in the reciprocal, so it's 2/y cubed. All right, and 24, because it's to the negative 3 power, I'm just going to put a 1/4g and make it to the positive 3 powers. So this would be 1/4 cubed g cubed, which would be 1/4 cubed is going to be 64, g to the 3rd, or g cubed. And there's our answer. All right, 25, we have a negative exponent, so we're going to move that to the denominator. And if there's nothing left in the numerator, it's just a 1. Okay, so 1/x to the 5th y squared. And for 26, I'm going to start out, my 5 is going to stay in the numerator, and I'm just going to move my m to the 3rd and n to the 4th to the denominator. I take the reciprocal and make them positive. Okay, 27, anything to the 0 power is just equal to 1. And we're assuming that f is not equal to 0 and g is not equal to 0. Okay, because you can't take 0 to the 0 power. All right, the next few get a little more complicated. All right, let's take a look. 28. So what I like to do is if I have negative exponents, I just like to move them to begin with. All right, so the 4/3, the coefficient piece stays the same. But my m to the negative 2, I'm actually going to move it to the denominator and make it positive. And the same thing with my n. Okay, now in the denominator I have m to the negative 4, so I'm actually going to move that to the numerator and make it positive, and then your n is going to be cubed. All right, so that would be my first step. Now it makes it easier, so I'm just going to subtract. So my 4/3 stays the same. I've got m, and it's 4 minus 2 is 2. And then I've got n is 3 minus 2 is 1. So that would be my final answer. Okay, if I look at 29, again, I'm going to start with my fraction bar. The coefficient 2, 3 is not going to change, 2/3. All right, my h to the 3rd, I'm going to keep that up top. My j to the negative 3, I'm going to move it to the bottom and make it positive. And my k to the 4, so I'm just working with the numerator right now. Now in the denominator, I've got a j and a k that don't move. All right. So now to the next step, I'm just going to kind of simplify. I've got 2h to the 3rd, k to the 4th over 3, and it's going to be j to the 4th and then k. Okay, and so when I look at this, I don't have any other h's, so I've got 2, thirds. I've got h to the third. My k I can divide, so I've got k to the fourth divided by k would be k to the third. And then on the bottom, I just have my j to the fourth. And I would be all done with that. All right, the next one, number 30. Again, I like to start with my fraction bar. Because the 3x is to the negative 3, I'm just going to pull it down and make it positive. And then up top, I have my y to the fourth. On the bottom, I have a negative, so I like to pull that out front so you don't think it's actually subtraction, so it's like a -1 coefficient. And you've got your x squared, and since we have y to the negative 6, I'm going to pull that up and make it positive. All right, so now I multiply my y to the fourth times y to the sixth, I get y to the 10th. And then down below, I've got a negative, and my 3 cubed is going to be 27. My x is going to be cubed, and then my x is going to be squared. Okay, in my final step, I'm just going to multiply. I've got y to the 10th in the numerator, negative 27, x is going to be to the 5th because I just add the two together. And there's our answer there. Okay. So scientific notation, actually, it's a number that's used, it's a way of representing really big or really small numbers. And we're assuming that you've actually learned scientific notation in 6th or Okay, had some technical difficulties there, but scientific notation, we want to put it in the form of c times 10 to the n power, where c is less than 10, so it could be like 9.99, and your n it's the exponent. So in standard form, if we had the number 16 million, okay, we could write it in scientific form. We put the decimal between the first two digits, 1.6, it would be times 10, and this would be to the 7th power. Okay, because we kind of think about moving your decimal over 7 places. 200ths is a small number, so we would write this as 0.02. We could write this in scientific notation by moving the decimal to the right, okay, and this would be 2 times 10 to the negative 2 power. Okay, so scientific notation is used to represent really big numbers and really small numbers. All right, so if we had to write the number 7,820,000, we would write this as 7.82, and this would be times 10 to the 6th power. So we're moving the decimal 6 places to the left, all right, to get to that decimal point, so the exponent is 6. All right, when you have a really small number, okay, we want the decimal to get moved to the right. So we want it to be between the 4 and the 0. So this would be 4.01 times 10, and this would be to the negative 3 power. We move it to the right. So we move it 3 places to the right. The exponent is negative 3. All right, so if we wrote these numbers in standard form, we could write this as 389, and then we would have 8 zeros after it. Okay, actually 9 minus 2, we'd have 7. Sorry, 1, 2, 3, 4, 5, 6, 7. So then we can write it like this. Okay, so the exponent is 9. We move the decimal point 9 places to the right, and that's how we got the 7 zeros. Okay, and if we have a really small number, in this case the exponent is negative 5, we're going to move 5 places to the left. Okay, when we do that, we end up with 0 point, and we've got, let's see, 4 zeros, 1, 2, 3, 4, 9097. Okay, so scientific notation in the questions you have with scientific notation, it's actually easier to just put them into Desmos at this point. So you might see a question like this on your SOLs, and we just wanted to kind of expose it to you. We really don't have a unit on scientific notation. So in Desmos, if you looked at it, I'm actually going to just show you these examples that I did. I did the first couple of them. So I just put the numbers into Desmos, and you can see for the number 1, I got my answer 7.84 times 10 to the negative 9 power. Okay, and then number 3 is another example where I put it into Desmos and I got the answer in scientific notation form. Okay, sometimes you're going to put it in and you might have to then convert it to scientific form because the number might not be big enough to actually be represented. All right, so for the purposes of time of this video, I'm going to ask that you refer back to the key to look at the answers for the rest of the notes and try some with the calculator. Okay, thank you. Bye.